Hey HLs, I wanted to just take a few more minutes just to look at Poisson problems, just in case you need a little bit of help looking at that. If not, it's fine. Anyway, so here we go. Question number one. We are going to assume the number of goals scored in a football match can be modeled by the Poisson distribution with a parameter of 2.9. And then we're going to let G be the number of goals in a particular match. So first we want to find the probability that the number of goals scored is 4. All right, so in order to do that, basically we know that then G is a Poisson distribution with the parameter of 2.9. And so this one we're looking just specifically for 4. So we're actually going to go straight to our calculator. And in the calculator, we're going to get the answer. All right, so we want the Poisson distribution. So we'll go into menu. We'll go to probability here and then go down to distributions. Poisson is down below the binomial. There's a couple other types of functions there. We may get to some of those this year, maybe not. But here we are, Poisson PDF. We want to know exactly 4 goals being scored. So we're going to go into the Poisson PDF. We have our parameter, which was given to us as 2.9. And we want the number of goals scored to be exactly 4. And so at this point, you have Poisson PDF 2.9, 4, which gives us a probability of 0.16215. And that's it for the first question. Let's go back to the question. So we got 0. So the probability that G was equal to 4 specifically is 0.162. I think 3 sig figs is okay there. I guess the parameter was given in 2, so you could do 2, but I think 3 is fine here. Okay, so 0.162. That was letter I. On to now letter II. So II is the probability that the number of goals scored will be less than or equal to 3. All right, now this again is going to be a calculator question, and this time because it's a combination, we want less than or equal to 3, 0, 1, 2, or 3. We're going to go ahead and do a cumulative CDF this time. All right, so let's return to our calculator. Now, if you want, some of you may get familiar enough with the functions that you don't need to go into the menu anymore. You can just type it. It also works. You could go into the menu, right? The next one we'll try to do differently, but here we go. If you remember the letter, you can actually just type in the letter on your keypad. Keep going. There we go. Poisson CDF. That's what we're looking for. Again, the parameter is 2.9, and we want everything from 0 up to 3 because it's less than or equal to 3 goals. Obviously, the goals can't be negative. We'll say OK, and there it gives us the answer of 0.669623. All right, so let's transfer that over to the question that we're working on. All right, so we found out that the probability that G was less than or equal to 3 was 0.6, and it was 696, so I'm going to round it to 670, just like that. All right, let's move on to the next one. So the next one is asking for the probability that G is greater than or equal to 4. Now, there's 2 ways to do this. The easy way is to recognize that the probability of B being greater than or equal to 4 is the opposite of the one that we just did, right? The one that we just did was less than or equal to 3, so that was 3, 2, 1, and 0. Obviously, 4 and greater is everything else. And so what you can do is you can do 1 minus the probability of G being less than or equal to 3, which would give us 0.330. Now, sometimes we'll recognize that and sometimes we won't. If we don't recognize that, I would like for you to be able to show you how we can do that on the calculator anyway. All right, so let's go over to the calculator and see if we get the same answer. All right, so now we're looking for the probability that the number of goals scored is greater than or equal to 4, right? So like I said before, you don't actually have to go through the menu. You can actually just, if you know what you're typing, you can just do Poisson CDF, and you'll notice that once I finished, it went from the italics. Here, let me show you again. See how it's in italics right now? As soon as I add the F, it goes into this normal type of print. That means that it's recognizing it as one of its internal functions. All right. Now the first number is always the parameter. Okay, so I'm putting in the 2.9, and then from there, we'll go ahead and say, well, I need everything from 4 up to, well, really we need everything up to infinity, right? We need as big as we possibly can get. Unfortunately, there's no way to type infinity in here. I've noticed that sometimes the number I like to put in when I do this is I'll go 1e99, but I've noticed that for some types of functions that number is too large, and so it will give you an error. And so I'm just going to say, you know, I'm going to put in 10,000. Okay, that should be a large enough number. The reality is that the probability of getting anything more than 10,000 goals is infinitesimally small, right? That should make sense that you're not going to get that many goals in a game. The probability is so unlikely that it's not really going to make a huge difference. And sure enough, when we push enter, we get 0.330, which remember is what we got when we were trying to answer this question in the first place. All right, back to the question. All right, so that was nice. Now we're on to the last part of this question. Let L be the number of goals scored in 5 matches. Write down the distribution of L and use it to find the probability of L being less than or equal to 10, given that L is greater than or equal to 2. All right, so let's go ahead and go straight into this question. The first thing that we need to do is, well, it asks us to find the distribution, right? Now, what that means when it says find the distribution is it means this thing right here. All right, so the first thing we want to do is find L is what type of distribution? Well, it's still a Poisson because we're still talking about an interval here, right? But now we're talking about 5 matches, okay? Well, the expected value, remember that for the Poisson, the parameter that's given is the expected value, and it's also the variance, right? Or in this case, not x, it would be g. Okay, so if the expected value in one game is 2.9, what is the expected value for 5 matches? Well, it should make sense that the expected value of 5 matches then is 2.9 times 5. Because each match we expect to get 2.9, and so in the end we get 14.5. Okay, so this Poisson distribution will have an expected value and therefore a parameter of 14.5. Okay, awesome. So let's move on. Now that we have the distribution, check, we should be able to find the probability of L being less than or equal to 10, given that it is greater than or equal to 2. Now, of course, this is a given that, and so I'm going to say the probability of L being less than or equal to 10, given that it is greater than or equal to 2, is equal to, and I'm going to use my formula, which is the probability of A and B divided by the probability of B. All right, so obviously what I need to do here is I need to find these probabilities. The probability of L being less than or equal to 10, probability of L being greater than or equal to 2, right? I need to find those probabilities. Now, this top one here, right, is less than or equal to 10 and greater than or equal to 2. So that means I need everything from 2 up to 10, right? Only the numbers between 2 and 10 will be less than or equal to 10 and greater than or equal to 2. Okay, they're both equal to, so I'm going to include both 2 and 10. So I need that one, and then of course on the bottom, I need the probability of L being greater than or equal to 2. All right, so we're going to go back over to the calculator and see what we can find. All right, so we are to our calculator. We're going to go Poisson, CDF. Okay, again, notice that it goes away. This time, remember, my parameter was 14.5. The first thing I wanted was everything from 2 to 10. All right, so I'm going to get that probability. And then the second probability I wanted was L being greater than or equal to 2. So here we go again, CDF with 14.5, and we want everything from 2 up to some really, really big number. 10,000 worked well last time, so let's take that one. So we've got that one, so a pretty good probability that it's going to be greater than or equal to 2. So now we just need to do the final bit, which is to take the probability from 2 to 10, which is the 0.144853, and divide it by 0.999992, which gives us our final answer of 0.14. Now, if you want, just so that you're learning what the calculator is capable of and that type of thing, you can actually do this. You can go Poisson CDF and then type in the 14.5 from 2 to 10, and then you can just divide that right away by Poisson CDF of 14.5 from 2 up to 10,000, just like that, and it'll do everything for you right at once. Okay, so it's not absolutely necessary that you do them individually. It is a good idea that if you do this, to write down either those two individual functions or this one, the big one on the bottom, on your paper so that the grader can see the process that you're going through as you're solving these questions. All right, let's go back to our original screen and wrap it up. All right, so when we put those together, we did get our final answer, which was 0.145, and that's our final probability. All right, so that's this first question. If you want, follow me to the next one, and we'll see you next time. Bye.